Okay, let's take a look at some examples here. Here's the binomial probability formula. This is if you're going to do it by hand, and some of you will choose to do it. I have students do that. And you learn how to plug it into a calculator, and then you get the answers to our probability questions, such as this in example 3 here. You have a probability that 85% of people have a Facebook account, right, adults. And let's say you choose 5. And we're interested in counting how many people have a Facebook account. What is the sample space for the number of successes? Well, that's 0 through 5, right? I'm going to ask 5 people, do you have a Facebook account? 0 may have any, 1, 2, 3, all the way up to 5. What is the probability of each of those events? And I have them in blue here. And again, we would use a binomial calculator on StatCrunch to do that. So let me get back to that real quick. So you would do stat calculators binomial, and then you plug in our constraints. We're going to be asking 5 people. That's fixed, 85%. And then you would do the calculator. Probability that 0 people don't have a Facebook account, given, again, this condition that 85% of the population does. So very unlikely, right, that we would observe 0 people. If I ask 5 people, that 0 of them would not have a Facebook account, given 85%. Again, as long as our sample is representative, a random sample. Less than almost 0%, right? Chance that 1 person out of the 5, and then we would continue through 2 equals 2 and so forth. And so then that's where I got these numbers from, and that's what in blue would fit into here, right? And so that's, again, our example here, StatCalc binomial calculator is what you would be using here to calculate that. But again, gets the sense of the probability that we observed this event under these conditions, right? 85% of go to Facebook. I asked 5 people, what's the probability that this many people would have an account under those conditions? Here's some more problems here that I need some answers, but before we do the answers, let's set it up here. The same situation, 85%, but now we're asking 50 people. What's the probability? Exactly 42, right? What's the probability? No more than 42. No more than 42 would be x less than or equal to 42. At least 42 is x greater than or equal to 42. X is the number of people, right, is that would have a Facebook account. And so we would do those calculations. So we have to change the scenario. Now, if you're doing it by hand, you need the Q. But for us, since we're using the binomial calculator, let's go ahead and recalculate this. So this is 50, and in this case, we have 85. So we're putting 42 in there. And so you get 0.149 for that one. That's so to have exactly, right, 42 people say they have there's a 14.9% chance if you ask 50 people. Now, we want let's go back real quick. For the next one was less than or equal to 42, no more than 42. And so less than or equal to, compute, and you get 0.481. So 48% chance that less than 42 people would have a Facebook account, right, under those conditions. And the other one was greater than 42, and you see 51.519. Make sure I got that right. Yeah, 0.519. And so that's how you would use the binomial calculator to do these calculations here. There are some practice problems that we would do in class here. Let's finish that here just so you can see it, given the scenario here. Check it if it's a binomial distribution, right? There's 2 success and failure. Each trial is independent of each other. We have a probability in this case. Your probability is fixed to 0.25, 25% chance of guessing right. Fixed number of trials. Those are your values. And then we would plug those in to get the answers to this. So your P is 0.25, and we're doing 20 questions. So 20 questions. 25% of guessing right, and we want to know what's the chance that you would get 14 correct. So I'll turn this to 14. It's only 20, and I want to know that 20 are correct. So sorry, that 14 are correct. Very unlikely that you're going to guess that. 0.00, 4 zeros and 257, right? So 0.1, 2, 3, 4, 256. So very unlikely you can guess 14. How about guessing more than 14, 14 or more? Then you just turn this into a greater than or equal to 14, because that means passing, and it's still very small. Same number, 0.0295. I mean, pretty much the same. 23295. It increases a little bit, but very little chance of guessing a 20 question test, getting at least 14 right.